guys, welcome back to Clever Coding. Today we're going to be talking and getting a little more deeper into the object-oriented programming paradigm. I know we haven't gotten our hands dirty into OOP, not yet by so far, but today we're going to be starting one of the important topics of OOP, and that is called the this pointer. So what this is nothing that big. So when we open up our dev C++, I have my skeleton already built for me, and what I want right now is to open and introduce my class. So after the using namespace standard, I write over here class, and I could make any kind of class I want. Like, we've discussed this already. If you haven't seen our classes introduction to OOP video, you can see it in the playlist. I hope this is like, it will be like the 20th video of the series. And so to get started by class, today we're going to introduce one called as Pokemon. So, and just for the sake of this practice, we're going to do it. So we're going to have some data members inside of this class. So for a Pokemon, we have a name, so we introduce name. And then we have something called the type, if it's a fire type, a grass type, a water type, and then the other one is the stage, if it's a level 1, level 2, or level 3, the maximum. Okay, so this is our attributes, and then we have our, which are by default private, set to private, and we have now a public access control, what I wrote, public over here. And after this, I make my methods, which will be accessed throughout the whole class. So the first method what I want to introduce today is called the void print this address. So I put this, and now I'm going to put this, and inside I'm going to define something which is just console output, and we're going to use this keyword, and we're just going to endline this. I know it could be hard to swallow this concept, and it's kind of troublesome for some of the beginners who are learning programming, but I hope that this video will find you guys in ease. So what this basically is just a pointer, like what we've discussed already. And if you haven't watched our pointer videos, I recommend you watching it before seeing this video. So this is another pointer, okay? And this stores the address of the current object you create. So basically we created a blueprint over here. So this full class is our blueprint, and we have to instantiate. So when we create an object over here, so by creating an object, we say Pokemon, and I create my Pokemon. So I say, let's create Pikachu. So Pikachu is our object, the thing we instantiated from our class Pokemon. So now Pikachu will be, first of all, I'm going to show the address of this in the memory, because we have discussed the address of operator. So I'm going to get this explicitly for you, and you could see this in the memory. So obviously it's stored in a hexadecimal notation. So before doing this, I have to save my code. So I'm saving it as 80, I think so. Okay, so 80. And now after that, executing and compiling, you'll see that the address of my object in the memory will be something like this thing over here. So if you could see this, this is a 0x6ffdf0, and this is a hexadecimal value. And what I want you to do now is to look at this attentively. Now after this, I'm going to use the method I've created in my class, which was print this address. So I'm just going to call this out. So now we're going to use our object. So we're going to use Pikachu, and then we're going to call our print function. So I'm going to use this function, print this address. And once I put a semicolon, and I know that it's just a void data type, which doesn't return anything. So I save this code, and once again, execute and compile and run. And this time you have to look at the addresses. They're going to be identical, because I used this operator, and this operator is basically the same thing as a pointer, and it stores the address of that object being created in the memory. So you have the same address. Okay, so after this, now what I want to do is create another object. So I could say Pokemon, let's say Charizard. Okay, and now after that, we have the same thing as explicit saying address of Charizard. So Charizard. And then we could have, well, we could basically say, sorry, this is not Charizard over here. The address of operator, this one. And now we could say the same thing as Charizard dot, and then this function. So now save this and execute, compile and run. And now you're going to see the address being changed, but not that far. They're going to be closer, but they're not identical. So you can see they're close. There's just a DF over here, and there's a DD0 over here. So you can see that there's a different object being created, and it's being represented 2 times, one with the address of operator explicit, and then using the this operator. So this is one of the options that this pointer provides us. The other option we have is that instead of getting the address, where we sometimes do need it, and this could be special when you want to toss the object address around and want to play with it and want to create another function and use an object. So this could get really handy for it. And then after that, we use another, there's another purpose for this pointer. And the other purpose is that when, for instance, we have a class, and we have these attributes, and then we have this functionality defined over here, and we create some other functions. So I create a set function over here, and I include something like string, and then I say new name. So like we did before, we are creating a set function, what are called setter functions, and we set the value. So we know that these are private members and they can't be accessed only until some kind of private function will access it through. So we use this setter function that could set the new name to the pre-existing name. So we have this name, and then we say the new name, what you entered as to that. So now we could like use it. So correspondingly, we'll have another method made as display, and we're gonna give 0 parameters to it. And what we're gonna prompt out is just a prompt that says name set to, and then we'll give the name. So by going into that main function, we create our class. So we say Pokemon, and I create an object, an instantiation as P1, and I say P1.set, and I want to set the name. So the name of the Pokemon will be set inside of this function. So it's a string, so I could name it as something like Charizard, and now this name will be set, but I have to access it, so I'm going to use P1.display. And once I put this, we're going to have this saved, and then execute, compile, and run, and you'll see that the name set to Charizard is working. So where is this pointer is observed? So some programmers tend to do this, is that when they have some kind of function already made, and when there's a lot of tons of code written in a program, and it sometimes gets confusing when other people start looking at your code and observing which variable is from the scope of that function and which one is displayed into the attributes, like ones which are related to here. So for that, we have this tendency to use this operator, and with this dash and an arrow symbol to indicate that this was already defined in the attribute section of the class. So it's just one coincidence, but for general purpose use, I would say that this is okay too. For documentary purposes, you want your code to be more documented, you could go for that. Another breakthrough point I love about this operation is that once you have something like name over here, so you have a string name, and you already know that name is already defined over there, but we cannot access it unless we get permission from this. So if the name is over there, and we know that where the compiler will try to run this piece of code. So when it tries to run this piece of snippet, what it does is that it says the string name is under the scope, and it's not over a board, so it just uses this. And then after that, there's this one too. So the compiler gets confused. So when we use this operator, we help the compiler by understanding that this one was used as a reference to the attributes being defined over here, and the other one, which is after the assignment, was the one which was defined in the input parameter. So this is also true, and this code could work perfectly. So that was it with this video. I hope you understood the concept of this pointer and you enjoyed watching this video. I would like you to dislike this video, and it will mean the world to me if you would subscribe to my channel, and we will see you guys in the next one. Peace.